Backtracking. The next one is backtracking, the problem which is associated with the top-down parser. So backtracking is nothing but the parse tree is started from the root node and the input string is matched against the production rules for replacing them. So backtracking is nothing but for a given grammar we have different productions. So if the production doesn't match, we'll go back with the correct production rule in order to get the given input string. So that is called as a backtracking. With the example, you will understand clearly. Let us consider the example grammar as S tends to CAD and A tends to AB or D. So the string we need to derive is CDD. So see here, S tends to CAD. Now again A tends to AB or D. So we doesn't know which one to consider. So we are considering as AB. Okay, A tends to AB. So what is the string we need to derive? CDD. But the string we got here is CABD. So for this, what again we are doing here? The problem where it is arised. So here the problem has been arised. So here what we are doing, we are again going back to the given production and using one more thing, one more rule. So that process is called as backtracking. So here consider here, see here. So A tends to, in place of AB we are using D here. So A tends to D. So the given input string CDD, we have derived the given input string. So now the input string is matched. This process is called as backtracking. So in order to derive the input string, if the rule doesn't match, if we go back and use one more reproduction rule from the given grammar, then that process is called as backtracking. So here we have some limitations. Those limitations are, if the given grammar has more number of alternatives, then the cost of backtracking is very high. And the next problem associated with the top-down parser is ambiguity. So you know already the what is meant by ambiguity. If a grammar produces more than one leftmost derivation or more than one rightmost derivation for some same sentence, then it is called as an ambiguous grammar. That is nothing but for the given production, if we are able to construct more than one parse tree, that is called as an ambiguous grammar. So consider here the grammar E tends to E plus E or E star E, E minus E or D. So the given input string we need to derive is ID plus ID star ID. So here we are using first E tends to E plus E. So in place of E we are using ID, that is E tends to ID plus E, and then E tends to, in place of V we are substituting with E star E, and E is substituted with ID, and again here E is substituted with ID. So finally we got the string ID plus ID star ID. So by using one production rule from the given grammar, we have constructed this. So we can use the grammar like E tends to E star E also. E tends to, we are using E tends to E star E. In place of E we are substituting with E plus E star E, and in place of E we are substituting with ID E star E. In place of E again we are substituting with ID, and E we are substituting with ID. So finally we got again the input string ID plus ID star ID. That means from the given input grammar we are able to construct more than one parse tree. That problem is called as an ambiguity or ambiguous grammar. So these are the problems associated with the top-down parser. So these are the problems associated with the top-down parser. Those are left recursion, left factoring, backtracking and ambiguity.